So we're covering the second half of 10.1 today, and these are going to be word problems. So this is actually some notes from last year, and I just am going to just make a video and talk over them to explain them, and I'll also post these on Google Classroom so you have them to refer to while you're trying the problems that you have assigned. So this first example, a wine containing 10% alcohol has added to it a 70% alcohol solution. The resulting mixture is 16% alcohol and fills 1,000 1-liter bottles. How many liters of the wine and alcohol does the wine contain? So this is typically called a mixture problem. So we have, because it's a mixture. So the thing, sometimes these can be really confusing, especially because you've got, you've got percentages, you have these liters, you have, all these different things taking place. So what you want to focus on is the very last question, or what the question actually is. How many liters of the wine and alcohol does the wine contain? And those are going to be your variables, and you want to be as specific as possible with your variables. So I would let W equal the amount of wine in liters, and A represent the amount of alcohol solution in liters. So then now I need to come up with equations because we have two variables, so we need two equations. So see the part that I underlined in blue here. We have 1,000, the two different mixtures, or the two different, it's going to fill 1,000 1-liter bottles. So that means W plus A has to be 1,000. So typically one of the equations is going to be pretty easy to come up with. Sometimes you're just adding those two things together. But then I have to get the other one, and I underline that in red. So a wine containing 10% alcohol has added to it a 70% alcohol solution. So 10%, if you change it to a decimal, you get 0.1. So 0.1 times W plus 0.7 times A. So that's the first sentence. The resulting mixture is 16% of whatever the solution is. So that's 0.16. And the reason I have 1,000 there is because I'm told that I have 1,000 1-liter bottles. I just as easily could have said, instead of the 1,000 here, I could have said W plus A. But we already know that W plus A is 1,000. So I put the 1,000 there. Then what I did next, I multiplied 0.16 times 1,000 and got 160. So just for convenience, you could have actually used this equation I have right here, but I did, I'll call it decimal busters because you'll probably know what I mean then, because it's kind of like fraction busters. I wanted to get rid of my decimal, so I multiplied everything by 10 so that it moved the decimal point one place, and I got W plus 7A equals 1,600. That's my second equation, so you'll see I have it over here. And then from there, you're just following the strategies that we did when you were just given the equations. So hopefully you'd be okay with it from there. And then you solve and answer your question. All right, so that would be that one. The next example is, and these are from that one's not your textbook. This one's from your textbook, so you'll have some problems like this as well. A gas station sells regular gas for $2.20 per gallon and premium gas for $3 a gallon. At the end of a business day, 280 gallons of gas had been sold and receipts totaled $680. How many gallons of each type of gas had been sold? So again, I start with my question right at the end. How many gallons of each type? So I like to use variables that kind of remind me of what it stands for. So I let R equal the gallons of regular gas, and make sure you put gallons so you don't get it mixed up with cost. And P equals the gallons of the premium. So I need an equation about the gallons, and I need an equation about the cost. So about the gallons, I'm told that R plus P is 280. So there's one equation already. And then about the cost, I have $2.20 times R, or just 2.2, you can leave it like that, plus 3 times P, $3 for each gallon of premium, equals $680. And then I just multiplied everything by 10. You don't have to do that, but I did to get rid of the decimal. So you can see this equation here. And then I just had these two equations to solve, and I used the elimination method and solved, and I got 80 gallons of premium, 200 gallons of regular. So those, I think one like this you'll find is not that hard. We've done some like this in Algebra 2. But these we didn't. I don't think we did any mixture problems in Algebra 2. I also don't think we did any like this in Algebra 2. So airplane speed. A man flies a small airplane from Fargo to Bismarck, North Dakota, a distance of 180 miles. Because he is flying into a headwind, the trip takes him 2 hours. So a headwind, the wind is, putting a force against him, so it actually takes longer. On the way back, the wind is still blowing at the same speed, so the return trip takes only 1 hour and 12 minutes. So on the return trip, you have a tailwind, so it's actually pushing you along faster. What is his speed in still air, and how fast is the wind blowing? So again, notice we're trying to find two different things, his speed in still air and the speed of the wind. So we're trying to find those two things. So I let A equal the speed in still air and W equal the speed of the wind. Now, the trick on this one is you are using the distance formula, which you may or may not be familiar with. And to get the distance, it's equal to the rate times the time. So we're going to make use of this formula. We know the distance is 180 miles. And note that it doesn't change. He goes 180 miles there, and he goes 180 miles back. So that's, a consistent distance. So that part doesn't change, only the time, the time does as well as the rate. So with the headwind, we're told that the time takes 2 hours. With the tailwind, we're told that the time takes 1 hour and 12 minutes, which conveniently I wanted to change to just hours. So you get 1.2 hours because 12 minutes is 1/5 of an hour. So then the rate with the headwind. If you're going with the headwind, that means you're going to slow down. The wind is going to slow you down. So you've got the airspeed minus the speed of the wind. And, that should make sense because it's slowing you down. The rate with the tailwind, it's going to make you go faster, speed you up. So you have the speed in still air plus the wind. So it's making you go faster, so it would be a plus. So using this formula, distance equals rate times time. With the headwind, I have my distance, that's going to be the same, equals the rate, which is A minus W, times the time, which is 2 hours. So I distributed the 2 and I just rearranged the sides of the equation. And then notice I can divide out a 2. And I get A minus W equals 90. So that's from this one. Then I come over here with the tailwind. Distance equals the rate, A plus W, times the time. And I distributed the 1.2, and then I just kind of flip-flopped it, so my variables were on the left. And then actually, I can divide out a 1.2 because it goes evenly into 180. So I get A plus W equals 150 for my second equation. So here are my two equations. Obviously, that's the hard part. Now you just add them together because the W's drop out. You get A equals 120 miles per hour, which means the wind would be 30 miles per hour because we know that you can just plug it back in. So like 120 plus what equals 150. So the wind would be 30 miles per hour. Okay, so that's how you do a problem like that if you're dealing with speeds and you're going to have to use the distance formula. On this next one, this is also from your textbook. A researcher performs an experiment to test a hypothesis that involves the nutrients niacin and retinol. She feeds one group of laboratory rats a daily diet of precisely 32 units of niacin and 22,000 units of retinol. She uses two types of commercial pellet foods. Food A contains 0.12 units of niacin and 100 units of retinol per gram. Food B contains 0.20 units of niacin and 50 units of retinol per gram. How many grams of each food does she feed this group of rats each day? And you get done reading that, and you probably just kind of go, huh? I have no idea where to start. So always start with the question and define your variables. So I have that underlined down here in blue. How many grams of each food does she feed this group of rats each day? Now, the food is not the niacin and retinol. The food is food A, food B. So it seems reasonable to use an A to represent the grams of food A because we're told that it was in how many grams? So we're told it's in grams. And then B, be the grams of food B. So those are my variables. Then I must have something going on, though, with the niacin and the retinol. So I need an equation that's about niacin and an equation that's about retinol. So the niacin I underlined in red. We've got, this is how much she has total, 32 units of niacin and 22,000 units of retinol. So that's how much she has total of those things. She uses two types of let's see, we've got food A contains 0.12 units of niacin. So for the niacin, I'm getting, for every gram of food A, she has 0.12 units of niacin. And food B contains 0.2 units of niacin, so 0.2 times B. So this is what one of the equations is going to be about niacin in terms of the two different kinds of food. And she has 32 units of niacin altogether, so that's what you set that sum equal to. Then for the retinol, we have 22,000 units altogether. Food A is going to use up 100 units per gram, so 100 units per gram of food A, plus 50 units of retinol per gram of food B, so 50 times B. And when we add those together, we get the total units of retinol, which was 22,000. So here are my two equations. Then I moved the I did decimal busters, multiplied by 100 to do that. Did a little bit of simplifying there. I think it looks like I divided out of 2 and got this equation here. I took my retinol equation that I had and looks like I divided out of 10 to get this equation here. And then I just did some properties that we have for elimination method and solved A equals 200, which means we have 200 grams of food A and 40 grams of food B, because you can just plug that into either one of the equations to solve for food B. And I don't think I got to that I was going to do another example, but last year I didn't get to it. So I'm not getting to it now either. But hopefully that helps you. You can refer back to these. You can refer to the notes page, because I'm going to attach this as a document on Google Classroom, so you can refer to that, and then you can work on the homework problems.